Good afternoon, everybody. I want to introduce our next speaker, Dr. Matt Young. Dr. Young is a biological dentist in Henderson, South Carolina. He's sponsoring our band, by the way, later. He's a Bachelor of Science from Davidson College, 1979, and his doctorate degree from Indiana University School of Dentistry in 83. He's our past president and currently serving on the IAOMT Board of Directors. Here's Mr. Dr. Young. Thank you.
Thank you. Thank you. Thank you. I don't think I need this. I'll just put it up here. Well, welcome everybody. Thanks for coming after lunch. I hope I can keep you awake here for a few minutes to talk about our study that we did. I do not have any financial interest of any product in my talk or any companies offering a grant money for this continuing education dental program. So let's make sure everything works here first. Yeah. As people were walking in, they were asking me where this picture was taken. And this is the Intercoastal Waterway. And if you played the ocean course on Wild Dunes, it's over here on the left. And this is a little island you see across from the Intercoastal called Goat Island. And we were coming back from a friend's house just as the sun was going down. So I'm lucky enough to live here some of the time in my little house we have down here, and then this is up in Asheville, close to where I practice. And this is my little girl Dixie. People ask me if bulldogs are smart. I said, well, yeah, I do have to help her with the newspaper, changing the pages for her. And this is Dixie, my wife Susie. I'd like to acknowledge her. She helped Joe and I mix all the amalgams that we mixed for our study, and we spent a couple hours after work one night and mixed up 100 mercury fillings and put them in some prosthetic teeth. So this is more of an update, more detailed information that I gave in the last presentation that I gave regarding the mercury vapor and particulate study that we did. And I'm getting an error message already. Dave? My pictures aren't coming up. Sorry, guys. Could someone ask Dave for the doggle that goes in the side? You got one? No, it's got my presentation on it. You don't think you have that one? What do you need? The flash drive that had my presentation on it, it didn't go over to the computer properly, so I'm missing all my pictures. It was sitting right there. Let's take about a 5-minute break here while I get the original program. We'll run it off the flash drive instead. Okay, thanks, Dave. We'll see when I get here to where the pictures are supposed to be. They're just coming up as a big X.
It comes off of that.
So put the thumb drive in, run it off that?
Yeah.
Okay.
Play it off your Sunday. Yeah.
Now, where do I go?
Just
Go out of Keynote.
yeah, minimize it. Keep it in.
Okay.
Yeah.
And go here.
Yeah. Either way. So yours is
There, that's it.
which one?
It's right there.
Okay.
Yeah.
the pictures.
That one works, and that one works, but when I get right to there, it just poops out on me.
There.
Yeah, but when you hit play on the screen, it's not coming across. I can just do it off that, yeah.
That's what I'm saying. Yeah. Want me to just go through and just see?
Oh, there it is. Cool. Sweet. Thank you. Everybody give Dave a hand. All right. So every speaker's nightmare, you get started and all of a sudden, whack, something happens. Okay, so this is some more detailed information over and above what we spoke about in Minneapolis. And Joe went over some of this in the fundamentals course, but I'm just going to go in some more detail with everybody about what we found. So when I was first thinking about this subject, I sit in my kitchen quite often at home and get my sketch pad out, and I drew this picture of a patient sitting in a dental chair and just visualizing in my head of if I could see the particulate vapor in real time, kind of what it looked like. And from that, we began to kind of design our study. And this is Joe and I actually doing the work the day we were working. We had a mannequin head with removable teeth. And Joe actually traced out a model of his body, and we cut it out of cardboard and made a mannequin body. And so don't let the equipment scare you away right at first, because we'll go into more detail about that. So my idea was to measure the level of mercury vapor and particulate using all of our IAOMT controls turned on, and then selectively remove them one at a time to determine the effectiveness of each level of protection so that we know, well, maybe one thing protects us more than another, and maybe one thing doesn't do anything at all. The layers of protection that we used were the tacked air ionizer, the cleanup, the high-speed carbon HEPA filter, which is the IQ Air. There's several different models of that's on the in the display out there in the other rooms, so I think you can pick your poison there. The reason why I chose the IQ Air is because it circulates 260 cubic feet a minute into the filtration tube here. We had high-speed water spray. It was a standard, cheap Japanese air-driven handpiece. We used standard high-speed suction, and then finally, at the very end, we drilled high and dry. We used the Mercury 3000, which is manufactured by Mercury Instruments, and Alex Hummel, I know you're here in the room, so Alex, raise your hand. I want to make sure everybody gets by and meets Alex and gets a chance to look at the machine in real time. He actually has a tooth with an amalgam in it. He'll scratch it for you, and you can see how the readings go up. But basically, the air comes in through a particulate filter to prevent big chunks of particulate from getting in the machine, and the pump runs at 2 liters a minute. Is that correct, Alex? Then there's a filter that automatically zeroes the machine out every few minutes, and so for every couple minutes you'll just get no reading at all, and that's because of the machine zeroing itself out. The mercury vapor goes through the optical cell, and the laser shines at it at a frequency, I think it's 635.7, in that range. And that's the frequency at which mercury absorbs the laser light. So then this is just like the detector on the back of your digital camera, only it's for the frequency of the mercury. And then the computer has an analog that figures out what the concentration of mercury is. And it does go all the way down to 100 nanograms, which is about 3,000 times more sensitive than what a Jerome is. And then this was the setup that we had in Joe's old office. Luckily, like I said this morning, Joe was getting ready to move out of this office, and we got it dirty as hell, to be quite frank, by the time we were done. And we got levels pretty close to 3,000 micrograms per cubic meter. And then we took an extra Jerome and went down the hallway where Carlene's standing. And even in the other room, 40, 50 feet away from where we were working, we were getting readings as high as 200, 300 in the adjacent rooms. So we basically left all the machines on it overnight to make sure it was safe to go in the next morning. So this is the Mercury 3000 over here. And there's a plastic hose that comes up here, and it's attached to my shoulder. And then a second hose went over and attached to Joe's shoulder. We had the tacked air over here, the air cleaner, and then Alex brought his laptop so we could see in real time what was actually happening. So that kind of gives you the setup, and luckily we had just a nice huge room for Joe to offer us to work in. So when we got to do the particulate sampling, We did 3 wipes on the assistant, one on the face, one on the chest, and one on the left knee. And the scenario here is this is 100 square centimeters. And that way the industrial hygienist is getting a similar sample from every single sample that they do. And they just use deionized water, and then they swab it off. The 2x2 goes into a test tube, and then that gets burned off in the laboratory so they can see how many micrograms of particulate is in the sample. So then on the patient, we did 4 wipes, one on each side of the chest, one on the abdomen, and one on the knees. At the first, I was going to do another, like a fly strip hanging from the ceiling so we could get a 3D idea of how big the cloud was. But by the time we added up all the info we already had, we had tons and tons of data. That would be another good study to do to see how far vertically it goes. But we know from what we'll see horizontally here, there's quite a bit of particulate coming off of there. So the particulate was one sample. Colleen had us hooked up to this air sampler. It's called a SKU air sampler. Basically, this pumps in a 1/4 liter of air a minute from a separate hose, and it was attached to our other shoulder. The carbon filter was attached to that, which detects the mercury vapor, and then there was a particulate filter attached to that in parallel, so that as the dirty air went through that, the vapor collected here, and anything that was a big enough chunk to go into the particulate detector went in here. And these samples were both burned off separate and added together for each session. She would determine a start time when we started drilling on the amalgams, and then she determined a stop time, and then that way she could calculate micrograms per minute, total micrograms too. So what did we remove? We did triple spills. Basically, we cut very large occlusal buccal preps on 2 and 3. Then we did large occlusal buccal preps on 31 and 30 on one side, and we tried to get a whole triple spill of dispersal oil to go in each of the teeth. Then on the second session, which we labeled, this was session A, on the second session we did 14, 15, and 18 and 19. And while we were using the cleanup, Joe would hold the cleanup over the tooth. Again, this was just a standard $90 Japanese handpiece. And he tried to keep my mirror as clean as he could with the air squirter. I don't know if dentists make as good assistants as our regular assistants or not, but yeah. We did have a learning curve. You'll see in the time graphs that we had the first session doing 2 and 3 and 30, 31, session A1 with everything turned on. It took us a while to get those 4 amalgams out because we were trying to coordinate our efforts here. The rubber dam was moved between the arch transitions, so we would put the clamp on number 2, take out 2 and 3, then we put the clamp on 31 and take out the lower. So there was a small time period in between the 2 removals that we had to transition the rubber dam, but that was no big deal. So here's the crowd. There's Alex and Bill and me and Joe and Colleen, and then that's Bill's clone. So to put this in a perspective now, EPA and this is the Agency for Toxic Substances and Disease Registry. They're a wing of the CDC down in Atlanta. And if a school has a large vial of mercury that gets spilled in a public school, then the ATSDR are the ones that fly up from Atlanta and help clean it up. Their action level is also 1. So anything above 1, EPA and CDC says you have to monitor. Anything above 10, ATSDR says that you have to evacuate the building. And then OSHA, as we all know, the 50 microgram per cubic meter over 8-hour time period is the maximum in a workday. And anytime your assistant or hygienist is exposed to more than 100, that's it for the week. They have to leave. One thing that we learned from Alex is that he works with a lot of different other industries besides dentistry. He works with the fertilizer companies. There's a company, I think, in West Virginia that you said had a big mercury vat that they use to extract chlorine in the manufacturers of different chemicals and stuff. And these people have to send in emails to OSHA every single day. This is how much our employees that they breathe. And they have alarms that go off, and everybody has to put on the masks. So, you know, how many dental offices do you know that have an alarm that goes off when it reaches 50? They're few and far between. And basically the OSHA level, from what we've heard, is a level that they tried to achieve because that's where the industry could get their factory to. If they tried to get down below 10, when they're making fertilizer or fluorescent light bulbs, they probably couldn't do it. They'd shut them down. So this is a more industry-dependent figure rather than a figure similar to ATSDR that's based on the biology of what happens to the human beings. And one thing that I learned from Colleen is that there's really no directive in OSHA for particulate. This is what it reads, compliance directive that states all exposed surfaces should be maintained free of accumulated mercury, which if dispersed would result in airborne concentrations in excess of the permissible limits or in a visible dust cloud. So basically OSHA says you got to keep the particulate clean off your working surface and make sure it doesn't get above those pill limits. So again, I sat at my kitchen table one night and I thought, well, how are we going to organize this data and how are we going to sample it and what makes the most sense? So this is just kind of a diagram I did. I want everybody to kind of get this image in their head as to where the data is coming from. So assistant's mask, the assistant's chest, and the left knee. We chose the left knee because it's closest to the operating field. If we had chosen the right knee, it'd be a little farther away, more parallel to where the patient napkin was. So we felt this would represent, from the assistant's standpoint, how much she might carry away from the room if she's done cutting an amalgam out and she's got to go help set up for Crown and Bridge next door. How much particulate is that assistant carrying around in her clothing? 4 and 5 is either side of the patient bib, 6 on the abdomen, and 7 was on the knee. Then these are the SK units that Colleen had set up for us. 1 on each shoulder. There's a carbon filter A, the particulate filter B. But bear in mind, when you see some of the raw figures later on, these numbers were relatively low, and I think that's because, number one, the pump has a relatively low volume per minute level, and these machines were designed for long-term walking around a heavy-duty plant with a respirator on and seeing how much you accumulate for the whole day. Whereas, as we were cutting out these amalgams, I think the longest time we had was 22 minutes, 23 minutes. And now you combine that data with Alex's machine, one side for Joe, one side for me, and we kept records. So we got basically 10 sources of data points for nearly 100 amalgams that we removed. Everybody understand that so far? Is that cool? All right. So really, in order to gain perspective on the whole picture here, we have to look at the particulate from the wipes in micrograms, the particulate plus the vapor, which was in the slow particulate and vapor pumps, and then the vapor in real time. And to me, when you see the accuracy of the Mercury 3000 and you see it in real time, and you know that it's in micrograms per cubic meter, that it just makes a whole sense. But when you look at all the graphs here in just a minute, you'll see there's a huge correlation between the different sets of data that we got from the different methods. Another thing is the readings do not take into account the synergistic relationship between the particulate and the vapor. Your air cleaner in your operatory may clean the air instantaneously, and if you had a Jerome sitting on the top of that patient, it may show up as relatively low. But if you don't throw away all those expendables and leave that particulate sitting in the room, it's going to continue to outgas. So to me, and what Joe and I discussed when we were done, there's this synergism that happens between the two. And whether or not we can deduce that from our data or not, we'll have more conversations about that. And then finally, before the machines were turned off, we waited 5 minutes after each removal before we tried to clean things up. Reason behind that is the larger particles are going to fall fast. The medium particles are going to take a little bit longer to fall and hit the surface. And the very fine particles, from what Mark Richardson was telling us, it could take anywhere from 15 to 20 minutes for those very fine particles to fall and hit the surfaces we were measuring. So I'd like to thank Dave Warwick for compiling these graphs. The one thing he wanted me to stress right now is these graphs do have a logarithmic axis, which means if we used a regular axis, I'd have to have a 50-foot screen in order to show the final two removals. So bear in mind when you see these graphs, it is logarithmic. And it really wouldn't do me any good to show you the raw data because it's just thousands and thousands of data points. So what Dave did meticulously was he looked through all the data and helped us come up with these graphs. So what I did in my brain, I thought, well, what's the best way to present this? What's the best way to think about it? So I'm going to present taking the amalgams out on the right right side first, left side second. And bear in mind, I'm left-handed. So when I'm taking out the amalgams on the right side, my hand may block a little bit of the particulate from coming out. This is with all the controls on. And this is in micrograms per cubic meter in real time. And you can see with the Mercury 3000, the tact air didn't make a big difference, but when we removed the cleanup, the level went up 233%. We removed the almost 300%. Then we removed the IQ air, it went up another 233%. We turned the water off and it skyrocketed to 74. Then we removed the suction and it went all the way up to 110. So you think about this is just an average. For an average dentist who accidentally turns his water off and his assistant just moves the suction away for a half a second, you've reached your pill limit for that day. Does everybody understand that? Yeah. Okay.
So that number 2.22.
Right here?
There. That to be clear, is that still using the IQ air, or is that with the IQ?
This is turning the IQ air off.
Okay. So at that level, average dentists that aren't using any of our recommended controls are still below that 10.
Right. Right. And you'll see with different measurements and different protocol, some of the other graphs, it will jump above that on a couple of graphs easy. Just I think of the overall picture and the trend that you're seeing here. But you're right. Then this is the assistant on the right side. The graph is much more linear, I think. And when we took the cleanup off, we got a jump of about 300%. Then we turned the IQ air off, and we got a jump 470%. Turned off the water, it went up 1,500%. And then high and dry, it's way up there. So, yeah, with the assistant side, this is, when you see the remove IQ air, this is the allopathic dentist typical scenario with just water and suction. Okay? Yes?
Do you do a comparison of IQ cleanup with rubber dam?
We had to rubber dam all the time, but we didn't do the cleanup without the rubber dam.
I wonder because you get much better seal without the rubber dam.
A better seal without the rubber dam?
Yeah.
Well, we can talk about that later, maybe so, yeah. This is the left side then. So with the left side with the dentist, you can see as soon as we took the IQ air off, we were above the ATSDR. And a lot of this I'm going to talk about near the end of my presentation. I think a lot of this had to do with our posture, how we had our hand in front of the drill, on the other side of the drill. One of my conclusions I'm going to say is if we could have removed 1,000 amalgams, we probably would have seen these roller coaster graphs become much more linear. So the dentist average was quite high on the right, and you can see it went astronomical here when we turned the water and the vapor off. Then on the left for the assistant, it goes up, then it goes back down for some reason when we remove the IQ air. Now these are just the averages. You'll see the peaks here in a minute. Remove the water spray and the suction, and it went way up. So for some reason on the left side, when we took the IQ air off, the assistant didn't get as much. And again, I think the posture that Joe and I had with each other at that particular moment probably blocked him from getting a pretty good reading from that point. So now we're going to discuss the peaks. And I think once you get to the peak graphs, you can see they become much more linear. Take off the tact air. Again, not a big difference. Remove the cleanup. Just about the same. But as soon as you turn the IQ air off, the peak starts to jump. Turn off the water spray, and again, it goes up pretty darn high. And then here's the assistant peak. So, see, there's almost a double in the amount from, well, more than that, almost triple between the dentist and the assistant with the exact same data set here. Again, take off the IQ air, and boom, you're almost twice what ATSDR says. Remove the water spray, remove the suction, and I think overall the assistant graphs were much more linear than what the dentist graphs were. So these are the peak levels for the left side for the dentist. And again, a little bit of a roller coaster here, but as soon as you take the cleanup off, then the peak levels go up for the dentist. Take the IQ up and it almost doubles. Remove the water spray and you're talking the sky's the limit with that.
How do you explain the drop in the mercury level when you remove the tact air 2 or 3 weeks?
No, Joe might be able to answer that better than me, but I think it was because it was so far away. It was a really big room, and I think it was just the overall distance from the work zone probably had something to do with that. Do you have anything to comment on that, Joe?
Well, not really. You'll see that on a few of the peaks and averages, but you'll see a little bit more effect as we get into looking at the peak.
Is it doing any good?
Well, I don't think it's. Can y'all hear me?
Go ahead and stand up, Joe. I brought some water.
Got a mic up there.
I think it's on. Test.
Is there a switch on the bottom?
I never can get them on. I'll just talk about it. I think the fact there is important that's doing a long-term cleaning, keeping the room environment clean, cleaning procedures. I don't think it's that big a difference when you're spraying the amount of material that you're spraying around, and it's just not quick enough to have it wet. Or maybe the IQ air just kind of overpower the effect of the tap air. But as far as it absolutely necessary for your protection, I don't think it's that big a factor. But maybe we could a study where we measure the room for 30 days, we're not doing procedures to see if things fall down, and it's probably more happening.
Yeah.
I would say on the scheme of things, I don't want to steal thunder, but the IQ air is probably the most important device we got in.
Yeah.
It's the most national deal.
Yeah, I think if you had a smaller room and the tact air was closer to your operating zone, and you had proper cold air returns and some laminar airflow, it might make a bigger difference. But it was a good 15 feet away from where we were working, wasn't it? About like.
Probably 10 to 12.
Yeah.
Quick question.
Sure.
How do you correlate, so the ocean number 15 micrograms per cubic meter over 8 hours? How do you correlate that with like these exposures?
Yeah, we'll talk about that here in a little bit. I'll try and put it in perspective for you. So these are the peak levels for the assistant on the left side, and you'll see I lost my mic. Okay, just taking the tact air off here went up a little bit. Removing the cleanup made it jump up really high. Then when we turned off the IQ air, it went back down again. So this is an anomaly again. It may have something to do with posture. It may have to do with the fact that we just haven't a big enough sample size. But for sure, you turn off the water spray and the suction, and you're sucking up a ton of mercury. So now this graph is very dramatic, I think, because it shows two different things. It shows the amount of time that each removal took. So as you can see, Joe and I took a little bit longer the first time. We were getting used to working as dentist and assistant, and then we became a little bit more efficient as we worked. And now this is the combination of the particulate and the carbon filter from the vacuum pump. And again, a little bit of an oscillation here, but as soon as you remove the water spray, it goes way up, and remove the suction, and it goes way up. But bear in mind, again, this was a very slow system as far as how much mercury it actually was sucking in every minute. The assistant, again, for some reason, the assistant was much more linear on some of these graphs. Removing the IQ air made it go up a little bit. Removing the water spray went up fairly high, and then as soon as the suction was removed, it went up. So just bear in mind the type of monitoring system that was used here. It's not in real time, and it was done indirectly in a lab too. So these were some of the numbers that people were thinking we were cooking these numbers, but they're not. Alex took the total amount of mercury vapor over the total time that we did it, and you can see 414. This was with everything turned on. That's still quite a bit of mercury that ended up being sampled for that time. Again, for some reason, we took the tact air off, it went down. As soon as we removed the cleanup, this is the total amount of mercury over the time that the amalgams were removed that the dentist could breathe. Now, bear in mind, the machine's going to be breathing in all the time. Human beings breathe in and exhale, half the time. So I think this is more indicative of what's actually happening in the real world as we're breathing next to our patients. Really, really high numbers with everything turned off. This is where we had to wait overnight for the room to get safe enough to even enter the room the next morning. This is the assistant's total mercury vapor. And this is extremely linear, so you can see everything turned on, turn off the tach air, it jumps up, take off the cleanup, and then as you go up, with everything turned off, it gets very contaminated. 191,000 micrograms. Now these were the wipe analysis of the knee, and what you're seeing here is the peak for every control. Everything turned on, the left knee is pretty clean. Turn off the tach air, a little bit more particulate. And that might have just been I was leaning toward Joe and I was blowing more amalgam onto his knee at that particular time. Again, I think posture and sample size has a lot to do with this. Take off the cleanup, and as soon as you remove the tach air, that knee really jumps up. Remove the water spray, it goes down a little bit, but it might have been, again, Joe might have had his knee up underneath the patient a little bit more at that point. But then with everything turned off, it really goes up. And now the last few graphs here. Again, this is the total time for each removal. This is the dentist average vapor using the Mercury 3000. Again, take off the cleanup, take off the IQ air, and up it goes. Okay, again, the dentist average vapor and the assistant. This is for left and right both, okay? So a little bit of a doggle right there, but everything's way above those levels. And so now this compares the wipe analysis to the Mercury 3000. So Dave was thinking, let's compare the two different sampling in real time is the little green dots, and using the wipe to measure the particulate is in the blue. So you can see it looks kind of like DNA. It's definitely going in from the low to the high, from left to right. And finally, this is the patient's peak particulate. This is the highest number of particulate that we got on the left chest with all the controls turned on. Remove the tach air, it goes up a little bit. Remove the cleanup, it goes up a little bit higher. Remove the IQ air, up another 800, and then it really goes up high. So this is the peak particulate on the patient's left chest and right chest, while the abdomen was really high here. The one point I think that,
Hey, man,
yeah.
just hit me probably what's going on with the tach air. The tach air is working on the particulate. This ionizing the mercury particles that are in there, not the vapor. So if we look at the tach air, those ones we're looking at vapor. If we turn it off, until it's not effective at all. When we add particulate to it, we still have to continue to combine with vapor. It's really not a true number, but sometimes it looks like it works, and sometimes it doesn't. And now we just look at the particulate alone, the surface sample to see if we do it.
Yeah,
That's probably.
that makes sense. Thanks, Joe. So pretty much, just to summarize the graphs, you can see from left to right as we remove our controls, they go way up. Again, I think a lot of this had to do with whose knee was underneath the chair, at what time, which way the air was being blown. Joe did a really good job keeping my mirror clean while I was working on the left side, and when you're working on the own side of the room that you work on, a lot of that air is going to get blown up into that hose. So, we could probably re-engineer the study if we wanted to get perfectly consistent numbers. Maybe take out 500 amalgams instead of 100. Maybe even can figure out a way to remove all the amalgams with the exact same time. And I think these little dipsy doodles in the graphs would go away. That's just my opinion. So as a result of this, Joe and I and Dave and maybe a few others have increased our level of protection on patients. And this is just what I do in my office. You can take it with a grain of salt. We do apply the non-latex rubber dam. And then I use LumaBlock, which is a bleaching agent to a bleaching blockout light cured material to seal the dam really well. We use a garbage bag. We found out that garbage bags and patient drapes are pretty good, as well as the Tyvek material that we use. I cover the face and the hair with a protective gear and put the suction up really close. I'm probably going to switch over to Dave's technique here pretty soon. He takes a patient napkin and he cuts a 3-inch hole in it Then he lays that napkin over the patient's face and then does the rubber dam over the top of that. So he feels this probably seals around the patient's face and around the hair better than what we were using. So we're going to call this the Warwick technique, the Warwick isolation, right? But the big thing was I was fortunate enough to talk to Alex and have him come and install a mass spec in our own office here. We have 8 different sample points set up. This is the way the operatories are set up. There's a particulate filter on the roof here. It comes down. I just use zip ties, and I have a spool of hose right here next to my blight, so that way we can add an extension cord to it. We can measure on the patient's chest. I can measure on the napkin, on the head of the handpiece when I'm done, pretty much wherever you want to measure mercury with this particular machine. And again, it's about 3,000 times more sensitive than what the Jerome is. Another neat thing is we have it set up so that I can look at the mercury from any of the PCs in the office, and I begin to notice every time I heard the autoclave go poof when it would vent and dry the instruments that we got a peak in the lab. And I kept thinking, I'm not taking any mercury out in the lab. Why am I getting a peak in my lab? And normally we keep the whole office about 2 to 3 micrograms per cubic meter throughout the whole day, and we were getting readings 8, 9, and 10 coming out of the lab. And I finally said, I think that peak's coming every time the autoclave pops open. So we determined there was probably some mercury particulate being left in the ultrasonic solution in the lab when the girls were done wash scrubbing off the instruments. And so we added the Mercury X, which is a mercury binding cream, to our ultrasonic solution, and then suddenly all the peaks went away. So that'll be one thing we'll want to talk about for the future. Is everybody familiar with the Mercury X? It comes from Action Technology. It's a cream, and we'll give you that information here later. Another neat thing is we're able to pick any of the 8 rooms that we have in the office to choose from. 8 was the lab. That's where we're getting the peak. I take mercury out in 6 and 7. These are hygiene rooms over here. This is my waiting room, and then this is my financial office. And thank God 1 and 2 stayed really, really clean with all the air filters going. And then if I happen to want to take mercury out in room number 6, I can go in here and click on room number 6 and tell it to sniff from that room for 2 or 3 hours, however long it takes me to take the mercury out. And then the patient gets a graph which they can take home. So this shows you the overall history of what the average was, and we usually stayed 2 to 3 micrograms per cubic, 0.2 to 3 micrograms per cubic meter most of the time. It gives you your peak for the last minute, for the last 5 minutes, and then Alex has this set up for me to where this actually emails itself to a Gmail account every day. So we have a permanent record that's kept off-site, how much mercury's in the office every day. And then if I'm sniffing in a particular room where someone's getting some amalgam removed, I can hit print screen on my computer, and then they get a copy of that to take home. So it's like, we took your mercury out safely today, and here's the proof. So again, particulate vapor, what's the difference? To me, the vapor is just the very, very small, minute particles that actually vaporized in the room. The big chunks are what you see on that patient napkin. When you're done taking your mercury out and you look down at that patient napkin, if you see little chunks of amalgam, those are just the big ones that you can actually see. Mark Richardson says there's micron and sub-micron sized particles, and it can take, again, up to 10, 15, 20 minutes for all those little bitty particles to settle in the room.
Did y'all measure mercury vapor underneath the dam?
No, we did not. We wanted to keep this particular study focused on the assistant because we knew what the OSHA regs were, and my whole idea since last year when I spoke at the American Dental Education Association meeting was to educate our allopathic friends, and if you go after them with the occupational exposure, there's not much they can say because we're held to the same standard as everyone else is. I did get an email back from someone from EPA, and they said, well, the patient's only in the room for a few minutes, and we don't have the time or the resources or the money to police dentists due to the EPA numbers. But I think if the patients knew what a dangerous level was, it's going to be a patient-driven system eventually. Yeah.
When you showed your diagram of your office,
Uh-huh.
mercury in those 2 rooms,
Yeah.
did you notice that there were unsafe levels in the rooms adjacent?
No. No, but we start the air filter a few minutes before we start cutting on amalgam, and then we leave it on. We leave it on for pretty much the whole appointment. Even while I'm doing my CERAC and polishing and all that, we pretty much leave it on the whole time. I had a Jerome before. It was practically a brand new Jerome, and now Alex has got it in his rental fleet, so you can call him up and rent it if you want to. But I noticed even with the Jerome, after you cut with the air cleaner on, if you turn that air cleaner off a couple minutes when you're done, you're still going to get some high numbers. You need to leave it on 15, 20 minutes after you're done. Yeah.
Inside the tube of the vacuum. There's a big vacuum.
Oh.
Inside that tube.
We didn't measure that. But I can go back to the office on Monday and measure it and let you know what it is. I think everything should be swiped down with the Mercury X, at the end of the day or at the end of the week. Especially all your females and your suction tube and inside your trap and all that. You want to say something, Joe?
Especially the part of the cleanup you keep. Because we did measure that. We did throw off about 300 feet. After we did. We didn't measure that. We did.
Yeah, if you put that dirty thing in your sterilizer, again, when your sterilizer pops open, it's going to be really high.
That's the question about the cleanup.
Yeah.
Do you use them? Do you throw the mercury that's on the inside when you put it in the sterilizer?
Well, again, if you use cleanup and you like to reuse them and recycle them, you're better off, swabbing it down with the Mercury X as much as you can. Now, Boyd Haley has promised us he's going to get a version of OSR that he's going to put into a spray. So we'll be able to spray everything down with OSR, and he says it'll irreversibly bind the mercury, making it a lot safer. So when that product comes out, that'll probably be a moot point. You'll be able to spray your hoses and stuff down. Yes, Pierre?
Yeah, there is a product called Mercon Spray. It's sold by Mercon Patterson.
Okay.
It's specifically made for that. It's a sulfur solution
Good.
instead of a cream.
Well, I got about 5 more slides just to kind of summarize things, and then I'll take some more questions here in just a second. So basically what we found out was that the IAOMT protocols that are taught in Basic Thursday are effective for mercury vapor. The mercury particulate and subsequent exposure needs to be addressed, I think, with further studies. We need to look at the synergism between the particulate and the vapor. We need to be very mindful of our expendable materials. They should be packed up and disposed of separately from the other waste. Do not stick the stuff with the gray sludge in with everything else in your office. Dave Warwick, we had a conversation a couple weeks ago. He takes everything that's exposed to mercury, takes it outside, puts it in an outside waste can, and leaves it open so it doesn't build up vapor. But then he took the waste bag, tied the top, and shook it up a little bit and left it out. And he's gotten readings as high as 600 outside of that bag. So you got to bear in mind, if that stuff all mixes in with your other expendable materials, you're going to contaminate it. And then if your help handles any of that without gloves on, then they're going to get exposed too. Some of my conclusions were that the Tactair was not as effective as we previously thought, but as Joe said, it's going to be a good adjunctive device maybe to use even just for psychological support for your other folks. The cleanup reduced the particulate significantly and should be used whenever possible. I mentioned in my rough draft on my paper that the only thing I didn't like about the cleanup, especially with the full face mask, is if you're getting close to the pulp, it's really hard to see. So a lot of times what I'll do is if I'm using the cleanup with my full mask, I'll just take the big chunks out, and if I think I'm getting close to the pulp, I'll wash everything down a little bit, put the half mask on with my loupes, and get the last little bit out with my loupes to reduce the chance of a pulpal exposure. The traditional water spray and suction gets close to the OSHA PAL limits, but well above the ATSDR in most of the graphs. And if you accidentally remove the water and high-speed suction, it gets extremely dangerous in the rooms. And I know that we all know this happens every day. The dentist accidentally kicks his foot switch off. The assistant's kind of reaching for an instrument and goes away from the tooth for half a second. So this can happen even in the best biologic dental offices pretty much all the time. So our protocols, I think, are keeping as safe as possible for now. The next level is once we digest some of this data, make sure it's accurate, is we're going to try and disseminate this to all the dental schools, the OSHA officers and trainers, and then look for future strategies for transmitting this information to other people. I know about 2 years ago, before I went to the American Academy of Dental Education, Anita got all the email addresses for me for all the OSHA officers and all the dental schools. So once we get our paper published, once we get this information available. We're going to plan on emailing that to all the OSHA officers in the dental schools and ask them for a action plan to see if they're concerned about mercury vapor and put their feet to the fire. I think that's going to be important. So I wanted to thank Joe for letting us use his office, for creating the SR paper that he's already submitted. Again, lots and lots of thanks to Alex. He gave us some huge perspectives from other industries that work with mercury. And anytime you want him to come and measure your office to make sure you're safe, I think he's got a portable instrument he can bring to you. We want to help Bill for helping out with the logistics, Dave Kennedy and Dave Warwick for their scientific support, and everybody at IAOMT. So, thank you.